This video will parallel the video you watched earlier. It will, however, take a more pencil and paper approach. The purpose of this is twofold. First, it will reinforce the concepts that you just learned. Second, it will give you a different viewpoint for calculating probabilities that you may see in different contexts. We'll use the same contingency table that we used in the previous video. This time, however, I will change the order of the questions I present to not follow the same pattern to challenge you to think about the type of probability addressed. Here is the first question. What is the probability that a house is yellow given that it is in the central region? This is called a conditional probability in which we restrict our sample space to the stated given condition, which is only the houses in the central region. This means that the denominator is not 1,000, but only 562. That is the total number of houses in the central region. Now it should be easy. In the column under central, we find that there are 123 yellow houses. Therefore, the probability of yellow given central is 123 divided by 562, or 0.219. Next question, please. What is the probability that a house is brown and in the north region? This is called a joint probability because we are interested in those houses that meet both criteria. Those are easy. Just find the intersection of brown and north in the table, which is 33. So 33 divided by 1,000 is 0.033. These are usually pretty small numbers. How about another easy one? What is the probability that a house is white? So the probability of white is equal to 358 divided by 1,000, which works out to be 0.358. This is called a marginal probability because we only work with numbers on the margin of the table. Let's add a twist to the question above. What is the probability that a house is white or in the south region? This one's a little trickier. So we use the general addition rule, where the probability of two events, A or B, equals the probability of event A plus the probability of event B, and then we subtract out the probability of event A and B and divide that by the grand total. So the marginal total for probability of white is 358. We add the probability of south, margin total of 254, and then we subtract out the intersection, 95, which works out to be 517 or over 1,000, which equals 0.517. Okay, now for a thinking question. What is the probability that a house is brown and blue? Assuming that there are no multicolored houses, these two events cannot happen at the same time, and thus the probability is 0.00 or 0%. We call this special case mutually exclusive. Almost done. What is the probability that a house is in the south region given that it is blue? This is another one of those conditional probabilities in which we restrict our sample space to the stated given condition, which is only the blue houses. This means that the denominator is not 1,000, but only 191. That is the total number of blue houses. Now it should be easy. In the row for blue, we find that there are 50 houses in the south region. Therefore, the probability of south given blue is 50 over 191, or 0.262. Finally, we finish with this question. What is the probability that a house is not in the south region? We call this a complementary probability. We simply find the marginal probability for a house in the south region, which is 0.254, and subtract it from 1. So this works out to be 1 minus 0.254, or 0.746. I trust by now that you are finding basic probabilities are not that hard to calculate. Most of the problem is in the wording. Think through the question carefully.